Okay, this is the multiplication rule for independent events. Now this might be something newer that we kind of maybe briefly touched upon, but maybe not in depth. So I'm going to quickly go through this. You're going to use the multiplication rule for independent events to calculate probabilities. You're going to calculate the probability that at least one using the complement rule and the multiplication rule for independent events. And then you're going to determine if it is appropriate to use the multiplication rule for independent events in a given setting. So let's go ahead and get that done. So now watch. What happens to the general multiplication rule in the special case when events A and B are independent? So what this is talking about is that in this case, the probability of B, given that A has occurred, is equal to the probability of B. Well, if you think about it, event A occurs doesn't change the probability that event B occurs, thus the definition of independence. So in this case, the probability of B given A has no bearing on B, so it's the probability of B. We can simplify the general multiplication rule as follows. If you have an intersection, probability of A and B, then you simply take the probability of A and then you multiply it by the probability of B given A. And what that ends up giving you is the probability of A times the probability of B. Okay? The result is known as the multiplication rule for independent events. So, this is just a general rule. So the multiplication rule of probability of A and B is equal to the probability of A times the probability of B. And you can use that if A and B are independent, but you can't use it otherwise. And then you can use this addition rule where the probability of A or B, where you simply can just add the probability of A and B if A and B are mutually exclusive, but again, not otherwise. And this last part is resist the temptation to use these simple rules when the conditions that justify them are not met. So if they're not met, please don't use them. Now watch, this would be an example of a problem. So you will have the multiplication rule of A and B. Well, the formula I just gave you says that if you multiply A times B, the probability of A and B, gives us another way to determine if the two are independent. Well, A is male and B has pierced ears. Well, are these two events independent? And the answer is no, and here's why. The probability of A and B, that means the intersection, is right here. 19 out of 178, okay, gives you 0.107. But you got one more step. We're going to use the formula that we just talked about. The probability of A times the probability of B is equal to the probability that, event A is male, times the probability that of pierced ears. So the probability of male is 90 out of 178. The probability of pierced ears is 103 out of 178. When you multiply those two, you actually get this 0.293. If they're not equal, then they're not independent. And that's basically it.